Hello, everybody, and welcome to part one of three of these webinars to get you all ready for the Barclays Hackathon in 2019. So we'll kick things off now. And if people join within the next 5 minutes or so, that should be fine. I don't think we'll be getting into the code, except in the in 10 minutes or so. So quickly, firstly, a point of order. So if you don't remember anything that I say in this webinar, you should remember this slide. These are your resources that you have available online for you for any documentation and reaching us out for help. So firstly, we do have a Slack channel, DerivHack2019, which is a public Slack where you can forward any questions related to the hackathon, Daml, or Dabble. Which is our cloud offering for the ledger. If you want to go old school, you can also email us at derivhack@digitalasset.com. Daml.com is your source for both the SDK and documentation related to Daml itself. So things like the Daml standard library, the components of a template, Daml syntax, all of the reference related to Daml is there. One caveat there, though, is that there's also a lot of documentation around the architecture and the APIs that you can use to connect to Daml-enabled ledgers. For the most part, you should ignore those because we'll be using mostly Dabble here. And there's a couple of caveats that we'll get into more so in the next couple of webinars. For how to connect to Dabble. It's going to look a little bit different than what is on the documentation currently around gRPC, for example. Lastly, projectdabble.com is open and available now. This is where you can quickly start up a ledger on our cloud offering, where you can quickly upload your Daml bytecode and have a ledger running in under 3 minutes. And this is the architecture on which we'll be hosting everything. Okay, but you can go ahead and log in there now and play around a little bit. But like I said, the details around that will be coming in the next 2 webinars. Okay, so this is what I wanted to do for the agenda. So I'll discuss the architecture a little bit, but then I'll dive right into the SDK and coding Daml. So most of this webinar will be spent within the IDE and showing you what to do with Daml, really. But first, we'll get started. We'll go over the architecture a little bit just to give you a high-level overview. Then I'll get into the live coding, which is, like I said, going to be the bulk of this presentation. So firstly, we're going to discuss the relationships between signatories, controllers, and observers, how to do multi-party workflows, and what do we mean by a Daml transaction. So that should be the bulk of it. And lastly, we'll discuss next steps. In particular, if we have time, I'll try to give you a little bit of a teaser for Dabble. Okay, so let's get right into it. Okay, so this is a very high-level overview of the architecture that we'll be using for the hackathon. So the light blue cloud here is Dabble. So that's our cloud offering for a Daml-enabled ledger. It will host Daml contracts there, which specify most of the rules of the game. So we're hoping that the bulk of your hacking during the hackathon is going to be using Daml to set up the relevant workflows, which will be hosted on that ledger. Talking to that directly are going to be Python bots written in a language called Dazzle. Yeah, that's quite a few acronyms starting with DA. But Dazzle is a Python library that lets you effectively write lambdas, which will react to creation and archival events on the ledger, and it will let you respond directly by putting things back onto the ledger. So this lets you build automations, auto acceptors, let's say, or small computations that you can't do in Daml for a variety of reasons. Including, for instance, that Daml contract must be deterministic. So if you need to do anything asynchronously, then you'll need to build some sort of a bot. So to go outside the bounds of the ledger of Dabble, you'll need to connect using a REST API. So you can, and it's a plain old standard secure REST API, which means you can actually just embed JavaScript code in your website if you'd like to. In addition to that, we've built some tooling around converting the CDM into JSON and uploading that into the ledger directly. And like I said, we'll be getting into that in the next 2 webinars or so. But for today, we'll be focusing mostly on how to write Daml contracts. We won't be getting into any of the sort of details around the architecture and how do we, the details of the CDM. This is more focused on Daml itself. So having said all that, let's get into the SDK and let's code. I was thinking of doing a simple use case where a person buys a service and this service becomes fungible or non-fungible based on the terms and conditions of that service. The idea is to show you how signatories will work together and how controllers work together and how you make assets and liabilities using standard Daml features and functions. Okay, so what I've done is I've gone into my shell here, and I'm going to create a new project called, let's say, Hackathon. By the way, if you haven't downloaded the SDK, I'd highly encourage you to do so. What it gives you, for the most part, it gives you this Daml command that lets you do a couple of things, including visualize your code, run an IDE with a lightweight ledger inside, and it's the main tool we use for writing Daml code. So I've created a new project called Hackathon, and it'll usually prompt me to say, maybe I'm not on the latest version. You can go ahead and download that if you like to. So Daml new Hackathon will create a new project for me called Hackathon. And to open that, I'll type Daml Studio, which will open for me Visual Studio Code. And immediately you get a small Daml program out of the box that you can use to test to make sure your installation is working. You know your installation is working when you can click on scenario results at the bottom here, and you get something that looks like the result of a SQL query on the right. Okay, but we're not going to be touching the main thing here. I'll create my own module for a paid service. Okay. I'll go ahead and pin the version of Daml on the top there. I'll call my module, let's say, paid service, and say where. Okay, as you know, we do assume a little bit of familiarity with Daml, but if that's not the case, I think you can still follow along and catch up with reading the necessary tutorials and then maybe rewatching the video if you need to. So what is a paid service exactly? It's something which binds together a provider of that service to the beneficiary of a service. This is going to be the description of the service. you know, it's just going to be a bit of text right now. But in sort of more complicated cases, this won't be text. This will actually be, let's say, the entire definition of an interest rate swap, let's say, or whatever the CDM will describe. So text is just unformatted, you know, it's an unformatted string of characters. But Daml lets you set up very sophisticated types that will provide like as the payload to your templates. And we'll say that, so who's the actual signatory on this contract? It should be the beneficiary because, actually, no, it should be the provider, my bad. It should be the provider because this service is just going to be the promise of the provider to do something for the sake of the beneficiary. So the signatory keyword here means that the provider must do something. He has the obligation. He has the liability to do so. He's liable for all of these things. Usually, at the very base case, it means that he has some sort of an obligation to perform off ledger in this case. In this case, you know, provide, let's say, consulting services or something like that. And just from an accounting standpoint, think liability. This is something you have to do. It's something that is going to be upcoming that you have to perform on. The flip side of that is being a controller. So that's obviously the asset side. So we'll say that the beneficiary is a controller, which means he may do something. It's an asset. It's a right. It's a choice. It's something that you get to do as a result of being labeled a controller. So we'll say that the beneficiary can, let's say, transfer this service to somebody else, making this thing completely fungible. And one thing here, if you think this is going a little bit slow, we'll pick up the complexity a little bit as we add some of the, let's say, non-standard Daml features. So this can get quite complicated quickly. So transferring the contract really means creating a version of this current contract, archiving the previous one, and changing one of the fields. So we'll say create this, basically means create a copy of this with the beneficiary equaling the next beneficiary. And I forgot to put in the argument here. Syntax error. I see somebody's already spotting my syntax error. All right, I'm gonna have a, see, this is why I didn't major in English. Beneficiary. There we go. Okay, perfect. Not this fine. Okay. This is working now. Well done, guys, in the chat for picking this up. Beneficiary. Oh, there we go. Beneficiary. There we go. But I misspelled it twice, so that ought to count twice. All right. Is everybody satisfied with this? All right, perfect. Well done, guys, in the chat. Okay, so what we've done here is we've granted the obligation to the provider to provide the service, and we've granted the beneficiary the right to be able to transfer this service to somebody else. And we can already write a little test case on this. So kind of one of the neat features of the SDK, and I'll blow away the left tab here, is that I can create my own, I can mock spin up a network and transact on it, kind of from like a God's eye view, to test my templates immediately. So let's see, let's create a couple of parties here, which has the effect of kind of spinning up a node in a DLT sense, or creating a user in the non-DLT sense. But so let's see. So we have one party whose name is Beth. We have another one, Manish. And we're going to create a service between them. So we'll say that Manish is going to be the provider of the service. And he'll create a service agreement where he is the provider, the beneficiary is Beth, and the service is going to be something like, I don't know, consulting services. Okay, great. So, and you can see the result of like what would happen on the ledger on the right-hand side here. So this is good, and it already offers some protections, right? Because if Beth tried to create this contract, we get the red squiggle underline of death saying that our scenario failed, and the ledger will tell us exactly why. And the reason is that we're missing an authorization from Manish. This usually means that you try to create a contract where one of the signatories never gave their consent. And then that's the case here. Manish never consented to this, even though he is a signatory of this contract. So this gives us some protection. Conversely, Manish can't create this contract either where, you know, Beth is the provider of the service. Same deal here. Beth never gave consent, so this is not going to work. Now, however, so let's but this sort of has some problems already as well. Namely, that let's say, what if Beth doesn't want the service, right? What if there's some cost attached to this? You know, that look, there's a cost of okay, Manish is creating the service where it's going to cost $1,000. It's not right exactly that Manish can just create this contract where Beth has to pay him $1,000, or seemingly anyway. Now note that even if the contract looks like this, Beth is never a signatory on this, so she can just say like, look, I never give my consent because I'm not a signatory on this thing. So this can this won't really hold her liable here, but nevertheless, we want to create a contract that does represent this type of service agreement. And the way to do so is to create, to make the beneficiary, there we go, I'm just gonna rely on autocomplete on how to spell beneficiary. So we're gonna make Beth a signatory on this contract as well. So that way, she needs to have given her consent to be put inside this position. On the other hand, when she does give consent, then she'll be liable to perform on this contract, namely pay Manish's fees. Okay. However, we get into a problem here with the signatories, because now Manish can't just create this contract. Okay. And the reason is the same as before. Beth never gave her consent. Now Beth needs to give her consent to create this contract. And she's not given it yet. Okay, well, so can Beth create this contract? And of course not. It's the same reason as before. Manish is the provider, and he hasn't given his permission. So you'd think there'd be something like this, where both of them give their sign on at the same time simultaneously and create this contract. But actually, if you think about it, these scenarios are simulating what would happen in a distributed environment, and in which case you can't ever guarantee that somebody is going to give consent at the same time. What if Beth gives her consent, but Manish unplugs his computer, and now the ledger is in some sort of an inconsistent state where Beth's view of the world is different than Manish's. Manish's is still from the time when he hasn't seen this contract yet. So therefore, we have to do something to allow to get the consent of both parties, and we have to do so completely on ledger. Now, one thing Manish could do is this. He could make himself the beneficiary of the contract. Now, and there you go, this works. However, the problem is that, this doesn't mean anything. He's both the asset and liability holder. So he's going to provide consulting services to himself and pay himself, like whoop-de-doo. But so what we must do is we have to create a workflow that lets us transfer this service to another beneficiary. Oh, and let's try one more thing here. So suppose Manish creates this contract, and then he also tries to transfer the contract to Beth directly. So we'll say that Manish exercises his choice to transfer, because remember now he's also the beneficiary of this, so he gets to transfer. And he'll specify the next beneficiary as Beth. And surprise, surprise, it still fails because we have Beth never gave her consent to this either. So there's never any way that this contract is going to get created without Beth having to do something. So let's give her the opportunity to do so. So we'll write another template which will represent an offer, a service offer from the provider to Beth, or to the beneficiary rather. And the signatory on this is going to be the original service provider and the original service beneficiary. And the reason is that you want both original parties to be able to sign off on the fact that this transfer is going to take place. You're representing the fact that if the next beneficiary accepts, both parties, both the original service provider and the original service beneficiary, sign off on all of the consequences of that acceptance, which in this case is going to be a service with the next beneficiary. So we'll say that the next beneficiary can accept the offer, which will result in a new service. and we'll say we'll create the service with the beneficiary being the next beneficiary. Okay, so the meaning of this choice is that we create a copy of the original service contract, except with one difference, that the beneficiary is the next beneficiary. And since the next beneficiary is a controller on this template, he can give his consent to become a signatory on this service. Because beneficiary is a signatory and next beneficiary is a controller, it means that this is the transfer of consent. This is how an asset becomes a liability. It's basically saying, yes, you know, I've exercised my choice to take on the responsibility of becoming a beneficiary on the service contract. Obviously, the liability there is going to be paying the cost of the service. And of course, the implication here is that he can also reject the offer, right? It means that the next beneficiary, he doesn't want the offer, and the way to represent this is to recreate the original service proposal. Oops. What this means here is that if the next beneficiary rejects the offer, then we simply recreate the original service. Okay, so let's see that play out. Oh, you have to wire this up now. So rather than this creating any new service, we're going to say this is going to create a new service offer. And we will say that create service offer with service equals this. Along with the next beneficiary. Okay, so now we have a bilateral contract here, which ought to work. So, so our scenario just works here. But the current state of the ledger is that, so Manish initially created the service where he is the beneficiary. He submits the transfer, and now there is a service offer on the ledger, the original service having been archived. So this replaces the original service, and we create a new service offer with all of the details that we want. So you can see this is the original service, and the next beneficiary is going to be Beth. And of course, we'll do the happy path on this one, and Beth will accept the offer. And at the end of that, we have a bilateral agreement between Manish and Beth for Manish to provide consulting services at the cost of $1,000 to Manish. Okay. Now, one thing I didn't go over too much is that kind of the payload of these templates. You can see that the templates comprise of basically the parties involved in a transaction and a payload, right? And the payload right now is just a bit of text along with cost and currency. However, this is also where you can put in terms and conditions. Like maybe we don't want this service to be transferable at all. In which case we'll say something like, do we want this service to be transferable? And we'll assert before before creating the new contract to say, assert that this thing is transferable, which means if it's not transferable, the whole thing will fail elegantly. So we'll say, let's say if Manish creates this thing to be not transferable, then of course, he won't even be able to submit the original transfer to Beth. So you can build up rather complicated terms and conditions here. And in fact, really, that's what the CDM is all about. It's specifying all of the different terms and conditions and specifying which workflow to take in each, with the different asset classes. Okay. So you can generally think of the CDM as providing a very, very rich payload for these templates. They provide effectively all of the term sheets of complex derivative products. And I would say the job of Daml in these cases is to enforce those terms and conditions and make sure that the derivatives and the assets behave the way they should on Ledger. Okay, so I'll make this true here. Okay, next, what I wanted to cover is the possibility of adding an intermediary to the service, something like an agent. Basically, Beth and Manish don't want to deal with each other anymore. They want to hire a third person to act as a go-between. So at the end of it, there's going to be two service contracts, one between Manish and the agent. Manish will still continue to provide his consultancy services, and Beth is still going to be liable to pay but she's going to be paying the agent. So there will be a relationship between Manish and the agent, and there'll be a relationship between the agent and Beth. If you remember last year's hackathon, this is actually the novation use case, where a central counterparty steps in between two counterparties to take on both sides of the risk of an interest rate swap. So we'll model this out here. Okay, so we want to say that the beneficiary should be able to designate an agent. We're not sure what this returns yet, so I'll just stub it out here. But we'll and the same rule applies here. We're going to be putting another party in an obligeable position, which means we need to give them the ability to consent to that. What we want to do is we want to represent that state where we've offered this thing to the agent, and he or she has not yet accepted. So we'll do, let's say, we'll create an agent offer with the service pointing to the copy of the current contract and the agent being the agent. So of course, we'll now need to create this agent offer template. And think to yourself, okay, so who are the signatories on this thing? It ought to be both the original provider and the original beneficiary. Simply because they have to be okay with whatever consequence arises from this template, which could be either the agent rejecting the offer or not rejecting it. Okay, so let's put in, we're of course giving the right to the agent to accept or reject this thing. He can accept the role, which will result in what? It will actually result in 2 different service offers. So we're going to create 2 separate service contracts here, where we say, so the first contract, so service 1, is going to be between the provider and the agent. So in that case, the beneficiary changes. And the second service where the provider changes, who's going to be the agent. And we simply return the tuple containing those 2 services. Okay, so the way this workflow will work is that the original beneficiary can designate an agent, which will create an agent offer. The agent can then accept that, and which will then create the 2 service agreements that we need. And now there's an intermediary called the agent who's going to be performing both the role of the beneficiary and the provider in the 2 contracts. Okay, so let's do this. So here, I'll just get rid of the syntax error here. So here, Beth is the beneficiary of the service. So she's the one that gets to designate the agent. Designate agent on the CID, with agent being a third party. Let's call him Georg. Okay. So what do we have at the end of this? We have an agent offer with all of the terms as before. So Manish and Beth are in the original contract, and we've offered this thing to Georg as the agent. And let's stick to the happy path here, and we'll say that the 2 CIDs will be accepted by Georg. So we can see the ledger update in real time on the right here. And after we've accepted this thing, we can see that Manish and Georg, so there's a relationship between Manish and Georg in this service contract, and a separate contract between Georg and Beth. So like I said, this sort of harkens back to the novation example from last year's DerivHack. Oh, and one neat thing here is you can see who sees all of the different contracts. Okay, so in this case, actually Beth, Georg, and Manish can see both all 3 contracts, but there's a little bit of a nuance here, which is that yes, all 3 parties are aware of the consequences. Oh, I should go back to the screen first. Yes, all 3 parties are aware of all of the resulting contracts. However, not all three parties are actually stakeholders on those contracts. So for instance, the agreement between Manisha and Georg is visible to Beth only because she was a stakeholder on the original contract, and she knows all of the consequences that can result from that contract. So she'll know that the only way that the original contract on which she was a stakeholder can disappear is in XYZ ways. So she'll know exactly what the shape of the resulting contracts will look like. However, Beth is not a stakeholder on this, which means she will not get notified if that contract is archived. So she'll know that it has existed at one point, but she will not be notified of any changes that happen to that contract. This is quite an important distinction here. So yes, sometimes contracts are disclosed to non-stakeholders, but even if that is the case, they will not be notified of any future changes to those contracts. Okay. So one thing I wanted to cover here is the optional keyword, because it trips quite a few people up. What if on the original service agreement, we can designate an optional agent? Like maybe, Beth knows going into the thing that this is going to be disintermediated, or rather intermediated. And she says, okay, I'm happy to do this contract, but this is the agent that I'm going to work through. So what we might do is we might provide an optional party on the original service agreement to say, look, that's the designated agent that we want. And you'll see optionals all over the CDM. Not every field is going to be necessary on the CDM. So what we will enforce here is when we create the agent offer, we want to assert that the agent is equal to the original optional agent. Actually, I'm going to change the name of this to opt agent. In other words, if the agent has been specified, we want to make sure that the person we're designating is that agent. Otherwise, we can designate any old agent. So one way to deal with this is to say, is to use case statements within Daml. We'll say if the optional agent is an actual agent A, then we'll say we'll assert that the A is equal to the agent that we provided. Otherwise, if it's not provided, then we don't do anything at all. Okay, so this way we say that, if there's an optional agent, we can go ahead and check to make sure that that's actually the designatee. Otherwise, we're going to return nothing. Otherwise, we do nothing. So we'll say the optional agent is going to be none. So we don't specify anybody up here. But let's say we did. I'm going to put myself in the narrative here. If we say that the designated agent is Georg, everything is working as before. However, if we designate myself as the agent here, we're going to get an error basically saying, look, you've designated an agent which was different than what you had, than what you specified up front. So now this is failing. Okay. So this is all of the Daml that I wanted to go through today. I hope it gave you an idea of how to move obligations and rights around from different people. Okay, I just got a note saying that I should talk about how disclosure works. So let's see. So let's go ahead and make this work again. So we're back down to Georg. Okay, and this is something I discussed a little bit earlier, but the reason, the way disclosure works, and the easiest way to visualize this is to look at the transaction tree. So this is a, let's call it more developer, less user-friendly view of exactly the same details as before. So you can see that we're going from transaction 0 all the way to transaction 4. And this models the 5 transactions that we've submitted in our scenario. So there's a one-to-one between each submit to each transaction here. And the way disclosure works generally is that the rule of thumb here is that if you're a stakeholder on a contract, you will get to know all of the consequences of that contract. However, only the direct consequences. So you may not know, like for instance, in the case where Georg accepted his role as the agent, and let's say Beth transfers her contract to me, to Levy. We'll do the so Beth will transfer her contract can't spell again, to me. Oh, that's the wrong contract. We will see that the original service is still known to all 3 parties, but now the service offer between myself and Beth, Levy and Beth, will be not known to Manish. So like I said, on the original contract, I'll just comment this out, Manish was aware of the service contract between Georg and Beth. And the reason for that is because he was a stakeholder on the contract which originated that consequence contract. However, he won't be notified, for instance, if that contract is archived, and that's what we see here. So it'll be divulged to him, but he will not be a stakeholder, meaning he won't be apprised if there's an archival. Okay, so that is all I wanted to cover for this Daml training. Now, what I'll do next is kind of give a teaser for what's upcoming. So there will be a separate training on Dabble itself, but I think you can already start playing around with it to get an idea of how it works. And the idea is very simple, actually. So I'm going to go ahead and go to Project Dabble. And I'm going to log in. So I'll go ahead and log in with my, my Google ID here. And the idea is that I can very quickly upload a Daml archive file and have a working ledger, within minutes. When I tried this last night, it took about 3 minutes. So I'll go ahead and run through that with you. So here I've logged onto my workspace. I'm going to create a new project. Let's call this the hackathon. And I'm going to create a new ledger. Let's call it, let's be very creative. Let's call it ledger. Okay. So now what's going on here is that there's an actual ledger being created on our cloud offering. We're setting up all of the rights, we're spinning up the nodes, etc. But in the meanwhile, I'll go ahead and compile my Daml code. So the way to compile Daml is you have to go into your daml.yaml file and just basically point your scenario to the Daml module that you've created. So this paid service test is pointing to this test scenario right here. And this is just so that the compiler picks up the correct modules. And on the prompt, I just type Daml build, which creates a DAR file in this directory here. So if we actually just cat this, not going to be terribly interesting. Oops. Here we go. It's a very very interesting bytecode file. So it's sort of the same thing as a jar file or a .class file in Java, or is analogous to. It's importantly, it's not actually Java bytecode. It's our own bytecode. So then I can go ahead and upload this file. I'll go pick up the actual hackathon file. And you can see that it basically uploaded to my workspace here. Okay, and then I can go into my testing ledger. There we go. And we can see what's there already. So I pre-baked something already to make sure I can show something, but the idea is you can quickly upload your DAR file, and then you can kind of see it in action. So you can create, I've already created the parties here, but you can add additional parties, which has effectively which is effectively spinning up a node on behalf of that party. And you can start adding contracts and exercising choices and so forth. So as myself, I'm going to create a service contract, which is going to be provided by me. Let's say to Beth, I don't know, wash the car for $100. And we'll say that it is transferable. And there's an optional agent. Let's say Georg's the optional agent. I'm going to go ahead and submit that. And then you can start basically start playing around with the contracts that get created here. All right, so there's one pre-cooked here. So you can, transfer, invite agent, etc. So you can very quickly upload your DAR file and play around. Okay, so the next steps. So there's 2 more hackathons upcoming. One's on October 2, and it's the DerivHack2019 guide to Daml. This is where we're going to get quite a bit into how the Daml works with the CDM. So the idea is to go through the connection between the CDM and Daml itself. The one following that, on October 9th at the same time, is to go through more of the architecture. So this is going to be a lot about Dabble, Dazzle, the REST API, and how to interact with your ledger. And I think that's it. So thank you very much all for your time. This session has been recorded, so we'll make that available to you. And so look out for an email from us. And in the meanwhile, I invite you to go ahead and start looking at these resources, particularly Daml.com and Project Dabble. And like I said, if you've got any questions, contact us on our public Slack channel, DerivHack2019, and or send us an email. Lastly, if you need support on Dabble itself, and I forgot to list this here, but there is a public Slack as well called Daml Driven, DAML-driven, where you can get support for Dabble. Okay, thank you very much.